This conference will now be recorded.
All right, I think we should be good to go. Can everyone see my screen? Let me zoom in a little bit so it becomes easier to see it. Welcome everyone to the bi-weekly Door Heat Exchanger call. I think it's been about 4 weeks since our previous call. So, thanks all for making the call. We have a few items on the agenda that I'd like to go over. And then, if we have time left over, as always, I leave the floor open to anyone on the call to either make suggestions or make comments about areas that this community should focus on. So the first topic is just a quick update. We have put in abstracts for presentations to the 2023 Global Summit. In total, we have submitted 4 topics. One of them is the Door Heat Exchanger sub-project update that will be presented by Jabari and Juan Carlos. Then we have an update on a white paper with the modular data center sub-project under data center facilities group in OCP, which talks about densification with the application of hybrid cooling. Hybrid cooling obviously being a combination of direct chip cold plates and door heat exchangers to enable 100% liquid cooling at the rack. This will be presented by Carl Rabe, who is the sub-project co-lead for modular data centers, and myself. Then we have another white paper that focuses on looking at microchannel heat exchanger coils for door heat exchangers and comparing it with the incumbent solution, which is the FinTube. And on that one, we have Sankar from Danfoss, who is on PTO but will be returning next week. And then Philip from Boyd, who has been like super helpful with getting us a lot of the information that we have been needing to do a lot of the analysis that we've been doing in this group. And then finally, this was a late addition, but this is a topic that Meta brought to the community a couple of months ago, and is still something that's in flight, which is the frame-based deployment of rear door heat exchangers. So by that we mean, what if you take the door heat exchanger and instead of it being mounted directly to a rack, you transition it to be a part of the facility. So now the frame is mounted to the concrete floor or whatever raised floor, however you set up your data center. And now the door heat exchanger, which traditionally has pretty long life expectancy, can be utilized for multiple generations of hardware. So this is something that's going to be presented by 2 of my colleagues from Meta, Saket, who is a mechanical engineer from the data center side, and then Jared, who is a mechanical engineer on the rack and hardware side. So this was a late addition that we put in, and we believe that this is going to be a pretty interesting topic for a lot of folks out there. And just a quick highlight: we put all these abstracts in on time. There's going to be a period of reviews across the cooling environments leads. And then there'll be a notification that goes out mid next month. And depending on the notification, draft presentations will be due towards the end of August. So we do have a good amount of time to start working on the material. I think much of it is already in flight. But anyway, just wanted to highlight the updated timeline because they did move the call for presentations out from Friday to Monday to give a little more time. But otherwise, I think the schedule for not only notification to the speakers, but also when draft presentations are due, stays somewhat the same. So Yeah, this is the first time we have had four we have had four topics to contribute. So, considering that the number of topics that get discussed in the cooling environments track is always larger and larger, it's going to be interesting to see, how many of these we can actually pull through. So, but anyway, the speakers will get notified, and when we do know about this, I'll also share it over here in the community, but it's looking good. Okay, that was just a quick update on topics for the Global Summit. Um, Before we move on to a couple of the more open topics over here, I just wanted to give a quick update on a couple of focus areas. So one is I do want to acknowledge and thank Boyd for the performance data that they have provided. This is to support the analysis for hybrid cooling in a modular data center. I'll quickly go over the data over here for those interested, but I don't want to spend too much time over here. Um, um, so Carl does know that we have submitted an abstract for the Global Summit. So both him and I have an action item to follow up on next steps for this white paper. And then, as I said previously, Sankar, who is helping drive the microchannel solution contribution, has moved back to India, and he should be back to work on Monday. So once he's back, I'll follow up with him on next steps related to the microchannel heat exchanger white paper as well. In terms of the performance data that was shared by Boyd, that's over here. I'm not sure if many folks have seen what we had prepared before, but effectively for the modular data center, the intention um, was to look at multiple knobs when it comes to doing the analysis. And one of those knobs was, okay, how much power do we have per rack? And we had highlighted 30, 50, and 70 kilowatt variants. The 30 kilowatt variant of OpenRack V3 is pretty much POR. All the documentation related to this should be available through OCP. The 50 kilowatt variant is something that's been proposed through the rack and power stream, as part of looking at 25 kilowatt shells with 5 kilowatt rectifiers. And the 70 kilowatt variant can be something like, okay, it's sort of future looking. We don't necessarily, sorry, let me rephrase that. There isn't necessarily a work stream that's focused on it currently, but we can consider this to be, something that's future looking, especially in terms of starting to push density to a really, really high end. Another variant is, okay, how much of that power is air cooled and how much of power is liquid cooled? Obviously, depending on how this ratio shifts, we have there could be more power that is liquid cooled with direct to chip core plates, or there could be more power that needs to be absorbed by the door heat exchanger in order to make the rack room neutral. So we have gathered a bunch of information over here thanks to Boyd, and there are a bunch of calculations that I did very quickly, but I already noticed that there's a mistake in here, so I need to go back and check that. But otherwise, I think for the hybrid cooling for modular data centers, I think we have all the data we need. And there are already a bunch of takeaways that we can highlight over here. One is when you really start pushing the limit in terms of capacity, it starts becoming pretty hard for the door heat exchanger to hit these performance limits that we call out as, QO ITD, which is basically the cooling capacity divided by the initial temperature difference. And sometimes even with doubling the flow rate on the liquid side, it starts becoming a pretty big challenge. And then the only option is to reduce the delta T in the air upstream to the coil. And the intention over there is to increase the initial temperature difference and make the Q over ITD term more reasonable or more feasible. So we do have this initial data that Boyd was very kind to give us, and I need to keep going through this. And Juan Carlos, I'll probably bug you to help me check my calculations. But I think otherwise, we, from a Doe heat exchanger standpoint, we have all the data we need to start putting together this white paper on modular data centers with hybrid cooled racks.
Yeah, okay, no problem.
All right, thanks. Okay, so those were a couple of quick updates over here. I do have a couple of open topics. One of them is, Jabari, apologies for putting you on the spot, but prior to us breaking after the prior call, you had submitted your thoughts on the existing requirements document and some proposed updates and changes. Do you mind just quickly going over that on the call so everyone's aware?
Okay, no problem, John. Give me a sec.
Let me make you presenter.
The PDF. I'll just highlight the comments, right? I won't go through the whole document. So, yeah, so this was the original Rev 1 of the Doe heat exchanger requirements for RV. I think this was updated for 3. But so I don't know if everyone's familiar with this document, but it just kind of goes through for a rear door heat exchanger deployment, some of the considerations you need to make for the different technologies. So I don't want to get too detailed, right? But what I'm going to do is just, what I did was I went through the documents and looked for things that would have been, or may have been, I should say, updated in other parts of OCP. So I guess that's still something that needs to be checked. And after that, well, once we have a line of sight of what those things are, decide if we need to actually update this document, and when that needs to take place, right? So there were just a few. I'll just run through very quickly. So I was wondering if this, I will have to check to see if this physical interface connection requirement here, for it to be 1-inch IDBSP type, if that has been updated, just based on what people would have done in other parts of OCP and the kind of flows that we expected in terms of the facility coolant. If we're still using 1-inch as the standard. And again here, in terms of the electrical requirements and the type of connectors, if that was updated in another part of OCP on the hardware management, I'm not sure. Again, same thing with the data. If these were still the kind of standard connections that you're using, or if these have also been updated. So those are the 3 in terms of cooling, data, and power. Those 3 categories just need to be checked to make sure that we're referencing things that still exist.
Yeah, I think this, Jabari, this list over here was kind of pretty wide in terms of trying to cover the, I guess, the waterfront, so that we were not, we were not necessarily excluding solutions from certain vendors. In terms of what the latest communication interface definition should be, I'm sure Mike might be able to comment on that. But yeah, but certainly we should be able to update that. I think the same thing with in terms of the physical connection for coolant. I think DSPP is pretty much the guidance from the ACF as well. But I think we've had discussions in this forum before, where it kind of depends on the end user. So it's kind of hard to We can certainly toe the OCP guidance, but I'm sure there'll be folks saying, yeah, but it depends on the end user because it could be NPT, it could be other things also. But these are good call outs. I think in terms of the pipe size, I think that's where folks who work with door heat exchangers can comment on. It kind of depends on the capacity. Like, okay, how much cooling is the door heat exchanger going to provide, or how much flow rate is needed? So I think certainly, if 1 inch or 1.5 inch is not going to be adequate, especially for like really heavy applications like the one that Ben described during the previous call, right, which was effectively like a 50 kilowatt door, then those are the kind of things maybe we need to look at and discuss and make sure that we are accommodating of those as well. So yeah.
Yeah, I kind of, it jumped out because I know that there's been also been a push to kind of move from C27 up to C32. So it was like, and that might necessarily, that might necessitate a larger bore size. So that was also playing into the highlighting of that. Hotter water is what I'm saying. If you have a warmer water and you're trying to cool with warmer water, then you need a higher flow rate, right? So yeah, I can check to see if there's any literature on that in terms of the update, but like you said, it depends on the end user and what they're trying to do. The next comment was on the OCP ready guidelines. Sorry, the class A1, sorry. Because there's been an update. There was an update from ASHRAE for the HPC. If you're doing air cooled, so there's another category, and that might be something that we need to update here. And also, this was using the old W class, like W1, 2, that was originally established by ASHRAE, and now we've updated it to the W17, 27, etc. We're actually referencing the water temperature maximum from 4 degrees to 17 or 27 or whatever your range is for your facility. So we need to update this as well. In terms, yeah, so ASHRAE guidelines for water quality, we do have this. We also have recently released OCP guideline. It's more for cold plates, but it does talk about treated water. And we probably need, I mean, we could just add in here that is not a new document to reference, especially if you have a hybrid deployment of a cold plate with a red or heat exchanger, and they're both integrated. And you need to use the more stringent of the two to kind of specify your fluid quality requirements. So that might be another thing we need to add in here.
Javari,
Yeah.
I remember maybe 1 year before we spoke about the maximal pressure, the brush pressure, the working pressure, and so on. And here is the also maximal pressure, working pressure, 450 kilopascal, so 4.5 bars.
Yeah, I think
think
that
it
must be
was
updated as well, Juan Carlos. So that's a good point because I think that's where we need to take the checklist, which was actually more recently updated, and make sure that the document and the checklist are kind of in line with each other or aligned with each other. I do recall
10 bars or something like that.
Yeah, I do recall John Gross talking about, hey, if it is connected to the facility water loop, then I think 1 bar or 1,000 kilopascals is kind of the reference point to design towards. So we can certainly make sure that this is reflective of that.
Okay,
Yeah, and
thank
then
you,
not just the 1,000 kilopascals, but also what sort of certification is needed for a door, right? It'll not be
Yeah.
68-1. It'll be 60. What was it? 60550 or something
335. 60335 minus 40. Yeah.
Yeah, something along those lines.
What was that? Sorry, Juan Carlos.
Yeah, we spoke about to increase the maximal pressure to 10
Yeah.
bars, I think, because in some cases could be the case if some valve is closed very quickly, you have a pressure increase very rapidly. The 10 bars could be nice to have. And the second is the brush pressure. Also, brush pressure means, okay, the working pressure is 10 bars, but the system will be broke by 3 times this working pressure. And this is defined by the 6335, then UL, another norm as well, but the ESA. But in UL, they will proof the systems with 3 times the pressure of the system to be ensured that is keep the pressure.
Okay.
Yeah.
It's 6335, right? That's what you said.
60335. Yeah.
Okay. All right. Okay. Thanks. Oh, sorry. Yeah, these are all highlighted under the same comment. It was all to make sure that we were referencing the latest OCP guidelines for propylene glycol untreated water that came out in 2022. So sorry about the 3 different highlights there. For the parameters, we did do a parameter table for the white paper last year on where we looked at the 3 different flow heat exchanger technologies. Maybe a good idea just to copy that one over here because it contains all of these values, all of these quantities, and then we could add in the ones that we would have come up with in that white paper as well. We don't have to, especially if it doesn't appear, but it's probably just prudent to do that. Sorry. Yeah. Yeah, I wasn't sure if this, I think this is a US government standard for impact testing. When you're constructing racks, and I haven't read it in a while, but it's a US government standard. I'm not sure if it's been updated, so it's just to verify this, right? And this one we talked about last meeting, where with the new OCP blind meat connectors with the manifolds that run on either side of the rack, and the new at the bottom, because the tolerances are so tight, we have new brackets that need to be installed on either side of the. So there's a new bracket that's supposed to go in here to accommodate the manifold to make sure that everything lines up, and it may interfere with the hoses and how we run the hoses at the base of the unit. So it's probably a good idea just to get some dimensioning done with a model to make sure that everything will fit. So, i.e., ORV3 optimized Redo heat exchanger and the new blind meat manifold, and make sure everything could actually fit into an ORV3 rack, and we don't have any issues with clashing at the base of the unit because of the new design features.
Yeah, I think Jabari over here. I think once we have a clear idea of what we want to add to the document in terms of dimensioning or some sort of routing study or so on and so forth, then I can reach out internally to see if I can get any support for that. So maybe as a starting point, we can focus on what sort of information would be useful to, the wider audience that would be reading this document. And by that, I mean, everyone who usually joins the call. Maybe we can take stock of what's considered relevant or what should be included in the documentation. And I think once we have a pretty good gauge of what needs to be added, then I can certainly check and see if I can get any support to do that.
Okay. Okay.
And in relation to OpenRack v3 and BlindMate liquid cooling for OpenRack v3, there are I know the latest drop for OpenRack v3 should be coming out in the next couple of weeks. There was already a short document that was shared with the cold plate community, sort of giving a preview of BlindMate liquid cooling. And I believe Glenn is also working on putting something together for the global summit. So there are probably going to be a couple of documents we can refer to over here when we talk about BlindMate liquid cooling for OpenRack v3.
Okay, that's good. That was the last one for me. Okay, I'm gonna hand back over to you, the presenting.
Yeah, thanks, Jabari.
Jabari, real quick.
Yeah.
Sorry, I joined a little bit late. I may have missed this window. Are we recommending a different pressure rating for door heat exchangers that are designed to connect to a TCS versus ones that are designed to connect to facility water solution?
So the discussion we were having was saying if there's no CDU and you're collecting directly to the FWS, you need to be able to handle the pressure. That's worst case, right? And if the upper limit of that facility water system is 10 bar, then your radar heat exchanger needs to be able to handle that. And then further to that, as Juan Carlos was saying, there's a specification for burst pressure from the UL 6335 that determines what the upper limit of that should be in terms of 3 times the. Sorry, am I not answering your question? Go ahead.
No, you are answering my question. I have to dig up my reference, but I believe there's an ACF recommendation that items that are connected to the facility water solution are rated to 100 or 1,000
KPA.
I'll have to check on that. Yeah, KPA. I will double check and get back to you. Okay, I don't want to pause people, but that would be the area. Obviously, a TCS would be a more conservative number, or it could be a much smaller number because the TCS doesn't have the volume pressurations. But the facility water solution, if we're just going any facility water solution, you could have a fairly large variation due to water hammer and a number of things.
Yeah, and I think that's where Don, we can probably explicitly call out the ACF guidance because it's part of OCP. And I think what we can say in the documentation is that if the door is, is in an implementation where it's part of the TCS, meaning it's downstream from a CDU, then we can say, hey, the pressure rating requirement can be much lower than what it is for the FWS. And I think there we can sort of leave it open to the interpretation of the supplier and the end user, right? Because then it depends on like, okay, who provides the CDU, right? So, then
the only thing I would say,
things can be more freeform, at least in my opinion. Yeah.
I guess the question is, if a TCS is being built, shouldn't we establish a TCS pressure range so that a variety of different CDU vendor or solutions could be used? I don't know what your thoughts are on that.
I mean, we can certainly gather information in this forum, but at a certain point, we'd probably have to take it to whoever's going to run the CDU requirements effort and make sure that, everyone involved in that, says, yeah, whatever you've defined sounds good. Because we can certainly, we have CDU vendors who join this call, obviously, because they also supply door heat exchangers. But I guess the question is, who's going to verify, whatever guidance we put out there, it needs to be verified by someone. So otherwise it'll just be, hey, this is the opinion of the door heat exchanger community only. So I agree with you, Don. I'm just asking, we'll probably need help with verifying whatever we put in here.
Right. It's one of those areas that needs to be, we're transitioning. We currently are in a boutique market where typically if you provide door heat exchangers, you provide the CDU and you provide the complete solution. But if we go to a cloud scale solution set where people are putting in a CDU and a pipe system and door heat exchangers, and 3 years from now they decide to use something different, they're not going to swap out their CDU and they're not going to swap out their pipe solution if they even, for example, want to go to a cold plate. If they can match delta T and delta P with the characteristics of the CDU, they may go to a whole different vendor of door heat exchangers or a whole different vendor of cold plate or something like that. I do appreciate there's more complexity in what I'm saying, but if we look at large scale deployments, we're going to have to get a broader base. At least that's my opinion, and I'd love to have people give me feedback on that. I don't want to dominate your call, but that's what I'm trying to kind of push for on the ACFs or when we start talking on the CDU things. So I'd like to know if it's possible.
Yeah, we can certainly survey the door heat exchanger vendors on this call in an offline conversation and get their thoughts on, what that range would look like. I don't know. Does anyone else have comments on what Don just brought up?
John, one question here. We are speaking about two loops. Different loops are pretty much different. I don't know if the cold plate community defined the maximal pressure of the secondary loop. I don't know. But for sure will not 10 bars or something like that. Because
Actually,
not
that's a
make
great point,
sense.
yeah.
Because if you have to coupling the quick couplings, the blind mates, the force to again the pressure will increase, and in some case you will not have force enough in your hands to put the server inside the system. So from my point of view, don't make sense to have more than 1 bar in the system if you are in the secondary loop. I mean 1 bar relative to the ambient because of some issues, but to have more will bring only problems. But maybe they discuss about that. Also the blind mate community.
Yeah, I think with the TCS, correct me if I'm missing your point here, Juan Carlos, but what I took away from that is the fact that between the door heat exchanger and the cold plate, I guess I don't want to use the term weakest link, but the component that's probably going to be more pressure sensitive is going to be the cold plate. And I think maybe go ahead.
No. Yes, I wanted to say yes, more sensitive for sure.
Yeah. So if the cold plate is more sensitive to pressure, obviously in the TCS, then maybe the pressure guidance needs to be defined by the cold plate and not the door heat exchanger.
Yeah. Maybe also the quick couplings, the blind mate couplings, they have too much to say, because if you want to connect it, you have to bring pressure or force against the pressure in the system.
Correct.
This is really high. It's really high. More power, more flow rate, and more pressure will more force because the surface of the quick couplings will be bigger. So I think it's not so to increase the pressure in the secondary loop to 10 bars. Okay, we can do that, but no one will do that.
Yeah, no,
So
there's no way it'll pass with 10 bars, that's for sure. Something in that loop will fail before that. So yeah, I mean, I can certainly so the ORV3 blind-mate liquid cooling group is a closed group. But I think this sort of information probably will come as part of the documentation that I said would be contributed prior to the global summit. So we can certainly refer to that information. I think when it comes to pressure rating defined by cold plates, I can certainly reach out to Cam Turner and see. I don't know, Jabari, if you've noticed anything, but we can certainly look at the cold plate requirements document revision 2 and see what's called out over there in terms of pressure rating. And then maybe that's what we use as a reference for the TCS. Maybe that's what we can do.
I can check. But you're saying that as a worst case, right? If there's no cold plate, then that you don't have to reference that.
Yeah, I think when it comes to the TCS, I think we need to look at other components, right? So if there's something defined for cold plates, we look at that. If there's something defined for blind mate QCs and is released and is published through OCP, then we can look at the lowest common denominator and have that as the reference point. I think that's the best that we can do over here, in my opinion. I'm happy to hear what others have to say. Anyway, let's follow up on this one, Jabari. We can do that and check back in during the next meeting.
Sure, no problem.
Okay. One last point that I wanted to bring up over here, and this is something that came up in discussion with Saket when I was chatting with him earlier this week on the facility door heat exchanger effort. And the question is, if we want the door heat exchanger solution to interface seamlessly with OpenRack v3, then there are multiple interfaces that would need to be defined, right? There's the physical / coolant interface. There is power. There is a communication management, and so on and so forth. But one thing that came up is, OpenRack v3 is pretty well defined as a 48-volt DC platform. Basically, you have a 48-volt DC bus bar that runs the span of the rack, and everything that's associated with the rack, apart from the power supplies, basically runs on 48 volts DC, or basically draws 48-volt DC off the bus bar. So the question that sort of arose in that discussion is, if we look at door heat exchangers as they are offered on the market currently, many of the fans that are implemented in door heat exchangers operate on AC. And the question is, if we start talking about door heat exchangers that are solutioned for OpenRack v3, just curious to know on vendors' thoughts on enabling 48-volt DC fans, whether that would be a pain point of some sort. If so, why? Or whether that would be fairly straightforward. Would love to hear from all the vendors on this.
I think we should use 48 volts because the idea behind 48 volts is to use as well the battery system to cover the backup system to cover the 48 volts USB. I don't know what is the name in English, but for sure, in case everything goes down and the rear door is connected to AC power, don't make too much sense. I think we should use 48 volts fans for sure, and I think it's possible. Maybe the only problem is to go through UL, but should be possible some way.
So Juan Carlos, did I capture? So the intention is to rely on the ORV3 power infrastructure, which is both the power supply as well as the battery backup units. Am I capturing that correctly?
Yeah, to connect everything to 48 volts, in case the current go down, the AC current, you have a backup which cover everything, not only the servers, also the cooling system.
Gotcha.
Because
Yeah.
maybe in the rear door is not a problem, but if you are using a RPU with a rear door, this works with AC power, and everything goes down from the cooling side, you have a big problem. So it makes sense to use 48 volts.
Okay. Thank you. Would love to hear from other vendors on the call or anyone else who holds an opinion they'd love to share over here.
I don't think the 48 volt would be any problem either.
Okay, so enabling 48 volt DC fan should not be a problem, or taking 48 volts in to the door heat exchanger solution should be okay.
Yeah, I don't think we need to have any kind of requirements as to what the fan power is. I mean, if a vendor could easily put an inverter in there and still stay with AC fans, you're just saying that you'd rather have the 48 volt input to the heat exchanger.
Got it. Okay, so if need be, can use an inverter to stay with AC fans. Got it. Anyone else? Okay, if no one else has an opinion, I'll take it as, yeah, thanks Juan Carlos, thanks Mike. These are good data points. I think obviously, you know, one part of the solution is going to be how do you take power from the bus bar and then feed it to the door heat exchanger. So that's one aspect that would need to be looked at. Okay, that's all we had on the meeting agenda for today. We do have about 8 minutes left. You know, appreciate everyone who joined the call. Is there anything anyone would like to bring up to the community in general that maybe has not been talked about in recent calls, but maybe should be in future calls? Anyone?
John, there is one system in which maybe we have to think about. This is the hybrid solution, the rear door with PAD with a CDU in rack. There is many possibilities to connect everything. We have to define it. But this is not the point in which we should to think about. The point is some customers want to be very efficient, others want to reuse the heat, and many customers come to me and say, okay, we want to connect it in series because it looks good and we can increase the temperature too much, because first go through the rear door, after that to the CDU, and then we could have double the temperature difference. But this is not the reality is much different, more complicated. And maybe we have to compare the solution in which we connected it in series and the other one we connected in parallel, because the results are interesting.
Okay, so series versus parallel connections between door heat exchanger and in-rack CDU. Is that correct?
Yeah.
Yeah, I think I think even from a physical connection standpoint, when we look at OpenRack V3, I think that's one area that where it's going to be pretty complicated or pretty tight,
Yeah.
because I think it's it's easy to assume, oh, it'll be a 3/4 inch pipe, but a 3/4 inch pipe may not be rated to pretty high flow rate. So
Yeah.
then it starts becoming a concern with, okay, we need to increase the pipe ID. Then the bend radius starts becoming a concern. So there are a bunch of things we need to look at over here. I agree.
Yeah. And it's not so easy like to think, okay, delta T in the reactor is 10 degrees, the delta T in the CDU is 10 degrees, we will increase the temperature 20 degrees. No, it's not so easy. And maybe we should do something to explain how it's working.
Okay, so performance analysis and, geez, if I could learn how to type. Performance analysis and physical interfaces, let's just call it that. Okay.
Yep.
I guess, should this be a part of the, maybe some commentary on this in the requirements document? Or do you believe this should be something separate, like something that's much more substantial, like like a door heat exchanger specification for OpenRack v3? I don't know.
I don't know if we should choose to write there, only to explain and after that decide what is the advantage and disadvantage of each solutions. And then we do the work one time for everyone.
Okay, yeah, I think we can follow up on this in future calls. I think unfortunately today we are almost out of time, but thanks for bringing this up, Juan Carlos. We can figure out how to follow up on this.
Yep. Okay.
Don, it seems like you have posted some stuff in the comments regarding a workshop. We do have a couple of minutes. Do you want to maybe publicize that to those interested?
Absolutely. So I appreciate the time slot here real quick. Data Center Dynamics is partnering more and more with Open Compute Project to give us floor space to have workshops. And so Monday, we actually have a workshop in Santa Clara from 9 o'clock to 11:30. And there'll be a 50-minute session where we're going to have a theme on Don't Fear Liquid Cooling Plan for IT. Speakers on that panel will include Todd Gale from Flex Central, who actually specifically has deployed and has great insights on what it took to add door heat exchangers on projects in the past and going forward in the future. And then we also have Terry Reniker from Equinix, who's VP for Hyperscale, and AlphaTech, the CEO of AlphaTech, and they have a fair amount of experience with, I believe, Meta and some other organizations, and HED is also going to be on the panel. If anybody here, or if you know people that are going to be in the area that would like to attend, I think we're going to have pretty strong attendance, but and we haven't been keeping this secret, but feel free to drop me a line or ask a question now. All righty.
All right. Thanks, Don. Yeah. So if we have nothing else, thanks all for joining.
One thing.
Oh, go ahead.
Yeah, really quickly. I am working with the concurrent maintainability group with Uptime Institutes and OCP. It's a partnership to kind of look at some of the considerations for people who are considering installing liquid cooling, direct liquid cooling at their facilities, and what that would mean for concurrent maintainability. And we just started talking about door heat exchangers today. It would be really good to get some feedback from the vendors or even the operators like Meta and stuff in terms of what they would have done in the past to achieve concurrent maintainability, and also some of the challenges that they've had with doing that, specifically with red door heat exchangers, any technology, right? We're trying to get that feedback from the community because it's so diverse and it's so nuanced in terms of the different solutions that people have implemented. It's just really good to get that feedback. So it's just push. It's the same day as this meeting. It's the same schedule, just 2 hours before. And usually it's just one meeting you'd have to attend just to give your feedback. It'll be really great to get that feedback, and it'll really inform the Uptime Institute because they're working on starting soon, I guess, a part of the TS certification process that would deal directly with liquid cooling. So it's good just to get, know what the challenges are from the manufacturers and the end users in terms of that TS certification for concurrent maintainability, and how that's achieved with liquid cooling. So you just need to get that experience. It'll be really great to get you guys. I can reach out offline if necessary, but if anyone's interested, please let me know.
Yeah, sorry, Jabari, you can certainly send an email to the Door Heat Exchanger groups.io address. And I think what I would suggest is to do that, and then also share information on when the next call is and what sort of information you're looking for. And then, if you can share the call information, then anyone who is interested in being part of that conversation can certainly join the call.
Okay, great. I will.
Okay, awesome. All right, if there's no one else, we are at time. Thanks all for joining today's call, and see you in 2 weeks. Thanks all.
Thank you. Bye-bye.
Thanks. Bye.
See ya.
Thank you very much.